the first question is always, can I master the clicker? And the answer is yes, that's good. So what I want to talk to you guys a little bit about is the buzzword AI. Everyone's doing it. No one's doing it. Every industry has solutions. Nobody has solutions. But I'm going to do it, and I've got to do it right now. That's the environment we all live in. All the speeches I've heard today, someone always makes reference to the same thing. It's impossible to find data scientists. It's impossible to find data scientists. It's even harder to find real ones, but I'll talk about that in a minute. So what I would propose to you is if you decide as an organization that you're going to create some AI application, start with something everyone else is already done. Pick something small and a common use case. Don't let yourselves or the organization you're with, or if your consultant, your customer, fall into the trap of saying, I'm changing my entire company by implementing AI. It's a recipe for failure every time. I picked telco just for fun. I've listed some common use cases that are proven. They either cut expense, they allow you to sell to universe of one, they give you higher customer satisfaction. You can, if you're in a different industry, go on IBM's website, go on NVIDIA's website. In Google, type in the industry, AI, you'll find press releases and use cases everywhere. Why start small? One, because everyone's afraid of AI, afraid of machine learning, afraid of deep learning. They don't know really what it does. Sometimes I think that those of us who are in this industry don't know what it really does, but that's a different discussion. You take small bites. Once you have the entire organization moving in the right direction, now you can start looking at one of the big bites. You'll read at the bottom a quote, and it's an imaginary quote based on a real life use case. So if you can't see it in the back, it says, sorry, Herr Newman, your interest rate on your loan is going up 2%. Since you scored high on our likely to divorce analysis. Now, if you're sitting there with your partner, significant other, husband or wife, and you think to yourself, well, wait a minute, I'm not thinking about getting divorced. Is there something I need to know? Where did this come from? Well, there's a financial institution, a bank, who decided that they had a problem with people defaulting or paying late on their loans. They said, okay, well, let me analyze my historical data. Well, as it turns out, if you get a divorce, especially in certain countries, you have a much higher rate of defaulting on the loan and making late payments. Because now you've had two incomes, now there's one typically. The person who's responsible may not pay on time. They said, okay, so we know this is a fact. Let me take my data, which is where every good ML/DL use case starts. Look at the data. They said, I'm gonna look at the customers who defaulted or were late on loans. Well, wow, a lot of those people were divorced. Okay, so let me subset that data, put it off to the side. These people paid on time, and they stayed married. Let me look at everything from their historical trends on payments to the number of properties they own, did they buy vehicles, every piece of data that bank had on their customers. That created a model that allows them to look at a customer and with somewhere around 80% certainty, not very certain, but 80% certainty, predict if you fit in a class where you're likely to get a divorce. Now, you're never going to tell your loan officer to have this discussion. However, the social implications, the company implications of doing this kind of analysis are profound. When you think about this is the kind of information you can cull from your records and predict about 100 people in this room, well, we'd pick 20 of you likely and say, you don't get a great interest rate because my deep learning project just identified you 20 as likely to be the 20 out of this room that will get a divorce in the next 3 years or the term of the loan. So the next thing you have to do when you decide, I'm gonna do AI, you identified a simple use case. Now what you have to do is figure out who's going to be involved. We say data science is a team sport. Deep learning and machine learning are a team sport. Lots of people get involved in your organization. So the first thing I tell everyone is, yes, you have to find your data scientists, find a consultant with data scientists, grow your own data scientists, And if you do hire a consulting firm or hire a data scientist, make sure they're a real one. I have spoken to far too many people, especially in the last 12 months, it's actually gotten worse over the last year, who say, oh yeah, I'm a data scientist. And after about 4 or 5 minutes of conversation, you figure out yesterday they were an Oracle DBA. It's not quite that bad, but it's pretty close. Anyone can print a business card. So then you have to say, okay, let's start with the data. Did I normalize the data? Am I confident in the data? Do I have one version of truth in my data? Lots of time is spent there. The next is I've got to prepare it. You'll see a later chart, and so I'll skip over it later because I've only got 14 minutes left. 80% of a data scientist's time, if you look at IDC or Gartner, 80% of their time spent on data prep. I just said it's impossible to find data scientists. By the way, you pay them a lot. The last thing you want them to do is spend time on data prep. It's 80% of the average data scientist's time. Then you build a model, and I don't care what open source framework you're using. If it's PyTorch, Theano, Caffe, TensorFlow, you spend the time there, you train it, you develop it until the point where you get a high level of accuracy. Depending on the use case, different levels of accuracy are enough. A colleague used one of our tools, and that's one of the things that we do, is we produce tools that allow data scientists to be much more productive. We also have a tool for those who use images that you'll see in a few minutes, any movies, pictures, and allows non-data scientists to create deep learning work. He managed in a very short period of time, hours, not weeks or days, to create a model that will detect a cancerous cell 95% of the time. Is that good enough? Well, what I can tell you is an oncologist who's doing research and only studying cells is about 95% accurate. An oncologist, someone focused on cancer, who only looks at 20 or 30 cases a day is about 80% accurate. If I'm launching a satellite into space, 95% accuracy is not enough. So the use case determines how accurate you have to be. You have to deploy your model. Your application developer is going to call the API to use the model. You're going to look at how your data is changing, and you're going to start the cycle all over again. So I said a moment ago, whoops, let's go back one. 80% of the time, sometimes automation works in slides, sometimes it doesn't. 80% of your time is spent here. There's a significant time spent getting up and running because you're talking about open source tools. You've got to integrate them, you got to test them against each other. As soon as you finish testing, someone released .16 versus .15, it breaks something else. Then you have to look at, this is CUDA, you look at CUDNN, and you're constantly creating this stack. This is a place I would tell you, lots of data scientists like to spend time. Can't tell you why. But they like to spend time being the latest, greatest on all the tools. So one of the things we did to make data scientists more productive is we created a free-to-download supported binary that integrates the stack. We have data automation tools that allow you to use Spark under the covers to normalize your data, so you don't spend 80% of your time there. We address the build, train, and optimize, as well as deployment and maintaining accuracy. So just raise your hand briefly. How many of you are comfortable with the difference between machine learning and deep learning? It's a good portion, good. When we started our products around this space, we were all deep learning focused. We've moved into machine learning tools probably over the last 6 months. So now we've got a nice set of machine learning tools. I posted something to my LinkedIn last Friday or Thursday that said, no, machine learning is not dead. I would tell you that when I speak, at least 4 people walk up every time and say, so when is ML dying? When are we going to stop with ML? We're not stopping with machine learning. Having the ability to trace the outcome back to the origin is critical in certain use cases. Compliance in the financial services industry. Why did I make a trade at 3:13 p.m. when the federal government comes in and says, this looks like it was an illegal trade, you may have had insider information. What caused you to make that trade? You better be able to trace every time back to the factors that led you to that decision. If you've retrained your model in the meantime and haven't snapshotted the previous model, you have a problem. So I mentioned that we have a tool that we have developed that allows non-data scientists to create image-based deep learning applications. Unfortunately, there's not time to show you a full demo of the tool because it's a lot of fun. This one is a view of what the tool looks like and how you use it. You pick your own labels into a GUI. You type a label name, car, person. There's a great demo we show that identifies Coca-Cola, Diet Coke, Pepsi, Sprite. The fact that lots of Coca-Cola bottles have people's names on them, they don't say Coca-Cola, and you simply put a box around it with a nice point-and-click mouse, create your label, train against that data, automatically label the additional images you put through the system. At the end, you look at your accuracy. It monitors it for you. It tells you whether you're trending up or down. Do you need more data introduced or not? Do you need to label more data yourself or not until you get to an accurate model? Yes, there is Caffe or TensorFlow under the covers. You don't look at that. Yes, we're running Spark jobs under the covers. You don't ever know that. It does hyperparameter tuning automatically. You don't need to know that. Yes, we use Spark to do it. The end result of which is a trained model that you can deploy as an API into any application. This is what our colleague did for fun with cancer cells in hours. We've had a common comment that we get from customers who have been playing with this technology is, wow, I spent 3 months, and out of the box in 3 hours, you were more accurate than I was. It's a fantastic, unique tool that came out of one of our labs that actually GAs in about 2 weeks, but we've had it in tech preview for months. So what else are we doing? Put that to the side. For data scientists, we have a whole series of tools that I'm not going to go through in detail. You can read them. A lot of you are very familiar with data science, so you'll understand the importance of these, that allow you to be more productive if you're doing AI work. So the hyperparameter tuning, having a GUI interface for you that shows the accuracy of your model, how the training is going, stopping it before completion. Long training windows are common when you have complex data sets. This allows you to monitor real time and then gives you advice. Are you doing overfitting? Do you have convergence of your data? This tool, and these are some views of what the tool looks like, comes together into a nice tool set that we call AI Enterprise. That's, as I said, a productivity tool. Machine learning, I have to talk about this because we only announced this about 3 weeks ago. Parallelizing ML code across GPUs without changing the code. We announced this at an event called IBM Think in Las Vegas, where we use this technology on a limited type of ML, logistic regression to be specific, where we showed that we could beat the previous record by 46x. I said we started with deep learning. We've got similar tools for distributed deep learning that allow you to accelerate distributed deep learning by 45 times. This is a unique case. We are actually going to tech preview this technology in June, and then sometime in the next 6 months it will become an actual product. A moment on large models. So most of you are familiar that a model has to fit within a GPU memory space. 16 gig up until recently, now 32 gig is supported by NVIDIA, and Danny from NVIDIA, who spoke earlier, is somewhere in the back. So yes, he's got the green tie on. We support, of course, both 16 and 32 gig. However, for those of you who are old like me, I remember when no one was ever going to use more than 640K of memory for DOS. That's absurd. Why would you need more data space than that, memory space? You're crazy people. One of the things we announced, a year ago at GTC, the US-based NVIDIA event, was large model support. Without changing code, the ability to support 2 terabyte data sets. We used system memory as a coherent memory space with the GPU memory. Because of our unique relationship with NVIDIA, we've actually put their technology of NVLink on our chip. It sits on our CPU. Now, Intel could do that if they want to open up their chip architecture and have a nice discussion with NVIDIA about how they could work together. Not typically Intel's business model. I don't expect it to happen soon, but I would never speak for Intel. What this allows you to do is a couple things. One, use much, much denser data sources, like high-definition images. I typically would tell you that no one I've ever talked to is currently looking at a 2 terabyte data set. 256 gig or so seems to be plenty right now. That need will grow, of course, and we will grow with it as we grow system memory in our architecture. This is distributed deep learning I talked about. 95% scalability with 256 GPUs. We can scale and take a 16-day training window. One customer I work with in the US that's doing research on breast cancer had a 9-day training window. They did not purchase a cluster large enough to take it down to a few hours, but they're now at 11. Didn't change their code. The technology does it for them. So I've got 4 minutes left, and I want to talk about a couple things to end the discussion. This is the most exciting space you can possibly be in right now. Use cases by industry are profound, impacting both how businesses run their culture. It has cultural impact on all of us. It has the ability to change how we live. My wife was recently in a car accident. Someone hit her from behind. This person was not a licensed driver, did not have car insurance. And I would tell you I had to take the car to 2 locations because our insurance company demanded it. They give different estimates. It goes back to the insurance company. They evaluate it. No, we were not at fault. Doesn't matter. So I would tell you I probably have about 11 hours into this discussion. I have a friend who has a different insurance company who literally took a picture of the damage. It's uploaded. They have a deep learning application that analyzes the damage, tells them how much it should cost to fix, gives you a list of places to go fix who will charge that amount, and it's done within minutes. You can guess, once I'm done with this very long process of my wife and my 7-year-old who are both going through physical therapy, once that's complete, we will be switching insurance companies. Why would I spend that time? Deep learning can have a very positive impact. The customer I was talking about with the 9-day training window is doing breast cancer detection. Their goal is to have every specialist spend at least 15 minutes with a patient. In the US, the average for a cancer specialist is about 3 minutes. How will they do that? Because people who don't have breast cancer will not see the doctor. The nurse will simply walk in and say, just want to let you know, test was negative, thank you for coming in. That allows the specialist to come in to the patient who does have breast cancer at a 92% certainty and say, look, odds are very high, we would like to do a biopsy now. What would you like to talk about? Are you okay with this discussion? You can't have a real human interaction in 2 to 3 minutes. This type of technology fixes that problem. Radiologists are hard to find anywhere in the world. Having radiologists and rural hospitals have access to basically the best radiology knowledge in the world through an AI tool. That changes how we live. We all know about autonomous driving. I have 1 minute and 12 seconds left. What I'd like to leave you with is, if you're in this space because you want to create an application, you have created an application, avoid tinkering. Let people who are in the business of creating tools create the tools. Don't get caught in proprietary. It will kill you every time. Anyone can innovate and have a moment of time, especially in this industry. And this industry is riddled with companies that had fantastic innovations. They led the world for a period of time, and they no longer exist. Watch out for proprietary. Wow, I can't even say it. Proprietary. With that, are there any questions that last less than 22 seconds? If not, I'll be at the IBM booth. I'm happy to have a conversation with anyone who's interested, and I appreciate the time today. Thank you.